Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the compound. The structure shown is vinylamine, ethanamine H2N, CH is equal to CH2. The question asks for the most stable conformation about the N-C single bond, the bond between nitrogen and the vinyl carbon. Step 2. Recognize the two limiting conformations about the N-C bond. Conformation A. Pyramidal sp3 in the nitrogen lone pair is not conjugated with the C is equal to C pi system. N is sp3 hybridized, pyramidal, with H-N-H bond angle 107 degree. The lone pair occupies a tetrahedral orbital pointing away from the pi bond. Conformation B. Planar sp2 the nitrogen lone pair is conjugated with the C is equal to C pi system, lone pair parallel to the p orbitals of the double bond. N becomes sp2 hybridized. The entire H2N, CH is equal to CH2 framework is planar, and H-N-H bond angle opens to 120 degree. Step 3. Determine which is more stable. When the nitrogen lone pair overlaps with the adjacent pi system, as in enamines and vinylamines, resonance stabilization occurs. H2N, CH is equal to CH to left and right arrow H2N plus is equal to CH, CH2. This delocalization lowers the overall energy of the molecule. Therefore, the planar sp2 form, conformation B, is more stable due to resonance conjugation. Step 4. Describe the Newman projection about the N-C bond for the most stable conformation. Looking down the N-C bond, the front atom, N, has two H's and a lone pair, the back atom, C, has one H and is part of the C is equal to C. In the most stable, planar, conjugated, conformation, the lone pair on N eclipses the pi bond, lone pair is SYN parallel to the pi system, making the molecule planar. The H-N-H angle is tilde 120 degree, sp2N. Step 5. Why the pyramidal form is less stable. Although sp3 nitrogen is the ground state for simple amines, example, NH3, tilde 107 degree, the adjacent pi bond provides a driving force for rehybridization to sp2 because the resonance energy gained outweighs the cost of rehybridization. Hence, the pyramidal conformation about N-C is the less stable form. Step 6. Summary. The resonance, non-conjugated, structure depicts sp3N, pyramidal, H-N-H 107 degree. The pi complex, conjugated, planar form depicts sp2N, H-N-H 120 degree, and this is the most stable conformation about the N-C bond. Therefore, the correct answer is resonance structure has H-N-H bond angle tilde 107 deg, sp3N, pyramidal, pi complex, vacant p orbital, form is planar, sp2N, with H-N-H tilde 120 deg. The correct answer is shown on screen.